It's fair to say that all of these non-technical considerations, if you might call them that, political, programmatic considerations, have perhaps doubled the cost.
So what about the future? Obviously, one of NASA's major priorities is to get the shuttle safe and flying again. But beyond that expensive and complex task, what? A space station has been one of NASA's goals since the 60s. And most people seem convinced that some kind of orbiting facility could be useful at some time, at some cost. But what design, at what cost, and when? There have been constantly evolving plans for an orbiting complex, resupplied by the shuttle, with living space, scientific labs, and experimental factories. Like the shuttle, it's supposed to do a little bit of everything for everybody. The idea was endorsed by President Reagan in his 1984 State of the Union address.
Tonight, I am directing NASA to develop a permanently manned space station and to do it within a decade.
It was supposed to cost $8 billion and be operational by 1994. In February 1987, NASA revised its estimates up to at least $13 billion. And Administrator Fletcher said the program would be stretched out so that 1995 would be the earliest it could operate.
Many of the pieces of rationale for the space station development sound an awful lot like the debates about the shuttle system back in the 70s. And I honestly have to say I'm concerned when I hear some of those things going on now, that we're not getting ourselves into the same type of situation as we did with the shuttle.
Despite Reagan's support, in January 1987, the President's Office of Management and Budget chopped $288 million from the space station budget.
One of the things that continues to be worrisome to me in the decision to proceed with the space station is that the central continuing element of the presidency, that is OMB, remained opposed to the project, just as they were opposed to the shuttle and squeezed the shuttle budget throughout its history in a very non-productive way.
I guess I have learned, I hope all of NASA has learned, is that you don't cut corners. When they start chopping back on the overall budget, you got to say, stop. We aren't going to build it if we're going to be cut anymore.
I think if we do continue on the present course of development of the space station, we will first of all find gross cost overruns. We'll find much more massive technical difficulties than are now anticipated. We will undoubtedly encounter a grave variety of safety problems. And finally, we'll find that it's not very much useful for anything.
Will the space station enhance or erode our nation's scientific objectives? Many scientists are concerned that last year, when NASA's overall budget rose by 12%, funding for space science decreased.
They have got to pay attention to the balance in their programs and not allow the concentration on getting the shuttle flying again and getting the space station underway to completely devastate programs that are already, in many cases, hanging by a thread.
One hopes that there is some learning in the system that you can't do big, ambitious things on the cheap. Ultimately, it comes back to haunt you.
Space exploration has generated an array of practical benefits: medicine and computers, communication satellites, and Earth resources mapping. And the new worlds explored by our spacecraft allow us all to live in an age of discovery as exciting as any in the human past.
Now, why is it important for the United States to do that? Perhaps in the long-range history of mankind it isn't. The science will get done. It may be done by Japanese scientists, European scientists, Soviet scientists. As a citizen and as somebody who would like to see the investment we have in our technical and scientific capability come to fruition and be realized, I'd like to see America be a participant in that.
We are now paying for a decade of benign neglect of our space policy. For the last 10 years, the amount of money being spent on civilian space as a percentage of our gross national product has gone gradually downward. So if we are to become leaders in space again, it will require a budgetary infusion of some significant amount.
To build a spacecraft, you need not just hardware, but also people to make the machines come to life with their dreams and hard work. For the scientists and engineers who fly the missions, it takes years of training in graduate school and later in experimental boot camp for a payoff of perhaps 3 decades of productive work. In that time, there might be at most 3 or 4 missions. But if Galileo is the norm, then the nation's best and the brightest might choose another career, and the human curiosity that must drive even robot spacecraft will be lost. On February 21st, 1987, about 14 months after it left JPL for the Cape, Galileo returned to be reconfigured. It will go back for launch in May 1989.
When we began Galileo, we thought we were going to launch in January 82. You know, we just had to swing with the punches. You know, we've been hit a couple of times, but by circumstances that were outside of our control, we've responded, and I think that's the way it has to be.
So what can we learn from the strange and rocky road of Galileo? That it's possible to build a spacecraft with parts that spin in different ways, but not to build a space program with policy and technical reversals every few years. That you can figure out how to stop computers from arguing with each other, but not to advance if Congress, NASA, and the science community cannot agree.
I'm not that pessimistic.
That it's possible to spin around distant planets to save fuel, but not to substitute wishful thinking for missing funds. In human, scientific, and financial terms, these have been expensive lessons, as almost everyone involved now agrees. In the case of Galileo, nearly $1.4 billion for a superb spacecraft